of operations that happens in the information pre-processing stage. So here, actually, you not required information, noisy information, pure information. So that kind of processing happens. For understanding of this. Now, once that pre-process, this is how goes to the here getting the optimum solution is the to here. So it is through changing behavior we try effectively we are
I don't have the permission to share the slides. Hello? I don't have the permission to share the slides. Allow me to share. Make me a co-host actually. Please excuse us. Just give me 2 minutes time. Ramesh, you have not saved it in a folder? It is already been downloaded actually. Or you allow me, na? You allow me, you make me a co-host. I will share it. Please make me a co-host. But I'm not seeing the share button. How do I share it? No, I'm not able to see that. Ah, got it now. Now got it. Just a minute. Yeah, Ramesh, are you able to see my screen?
Hello, everybody. My name is ICMIB. I'm a coordinator of EU R&D projects 5G Heart. So today my presentation title is AI-enabled 6G networks and applications. So I'm very pleased to have opportunity here to make vision and aquaculture. Okay. Next things about the AI. So many people now say the AI is obviously virtual world. Everybody think that. So especially the image processing and video or smart factory, they are using the AI techniques brings a very, very big impact. So, but on the other hand, many people little confusing. AI is almost human, but actually that's not true. At the moment, state of the art AI is just a goal-oriented, singular task. That's the only thing the AI can do. So what can do is the clustering, classification, regression, and decision making. Using this task, there are obviously many things we can do, like voice recognition, image processing, driving car. Recently, everybody already know about the ChatGPT. So last year, ChatGPT was released. That performance is incredible. So when people think it's almost like a human, but ChatGPT is also composed of the many different types of techniques. Obviously, that is including the AI, big data, and language testing, the language technology. So the AI also have the one singular task, and combined with other different technology, we can have the many good product and services. Okay, so what you can talk about the AI in 6G is basically two angles. The one angle I can say like other area, AI improved their performance. We can improve the 6G performance using the AI techniques. In this topic, I wrote the one book last year. I published this book, The Artificial Intelligence for 6G. So I'm including this content in this book. So I will very briefly talks about how AI techniques improve the 6G performance. But this is very thick book, over 500 pages. So I can't tell everything. Just very briefly talks about this book contents. Next angle is the ecosystem. So we can say the AI and 6G in one new ecosystems. As I said, I'm leading the EU R&D consortium with the 5G HUDs. We developed many different use cases using the AI and 6G. Actually, the 5G, but the 6G is still under developing, so we can sneak peeks from the 5G techniques. So probably you can have some more hint from this activity. So another angle is the ecosystem. So we developed the use cases using the 5G, 6G, 5G and AI. Then you can see what ecosystem we can have in the era of the 6G and AI. Okay, first of all, I want to talk more about the 6G. So what is the 6G and timeline, and what is the example of the AI in the 6G functions? First of all, I need to talk about the spectrum. So the 5G spectrum is basically composed of the three parts. First part is low band and the mid band and the high band. The low band is used for the IoT services. Mid band is basically using the normal operating. And the high band is for the small cells, the high data throughput transmission. As you know, especially the millimeter wave band, they have very huge bandwidths. We can provide the very high speed transmission in this area. Likewise, the 6G also have the three bandwidths. So even if this is still under discussion, probably there will be the same like this. So low band, the B band, and high band. In the high band, we are considering the terahertz communications is much wider than the millimeter wave, so much higher speed that we can have. All right, and next is about some key features of the comparison of the 5G and 6G. 5G, as I said, they have many different type of use cases they included. Let's say ICMIB, LSC, MMTC. So including this, obviously the 6G will take the whole capability of the 5G application and add more the services and applications and new techniques. So the ICMIB, URLSC, and MMTC will be included, and we could have between the two different applications, let's say the ICMIB plus and also URLSC, that could be the application we are now developing in the 6G topics. And also in the key services, UHD video streaming, V2X, IoT smart city. Then we are also thinking about the holographic video streaming and tactile internet. In the technical networks, key network feature point of view, the slicing, virtualization, cloudization was the key feature of the 5G. In 6G, on the top of that, the network will be the more intelligence. So they are also the key, including the new key technique like that. So next slide is about timeline. Yeah, the many people say about the one generation covers is basically the 10 years. So one generation is lasting the 10 years, then the overlapping a little bit, then we developed another generation. 6G development started in the actually this year almost that it will be developing last 7 and 8 years. Then the first AI will be appears around 2029 or 2023. So the kind of overlapping will be held. Next, this is one example of the AI-enabled 6G functions of an OpenLAN. That's the OpenLAN is now under developing. So this is one of the key concepts of the 6G now still developing 5G networks. And previously, basically mobile operators deploying the core networks and the LANs, radio access networks differently. Basically, they are selecting the one vendor to develop the core networks and select the multiple vendor for the LAN. Because it will be very efficient if you have some good interfaces, interoperability is maintained, and we can invite more the vendor. That will be the lower the barrier of the new competitors. So now they are doing and makes more open and interoperable. The LAN will be deployed. So the basic concept is the key function of the radio networks will be deassembled. So then we're gonna develop the interfaces and interoperability. Then we're gonna operate more flexibly and the interoperability. So in order to deploying this kind of concepts, we are using the AI. So AI could find the good combinations of the LAN functions. So this is still under discussion. AI will be very important role in this open LAN concepts. Okay, the next, Now I'm going to talk about how the 6G AI will improve the 6G performance. There are multiple approaches. In the we can see this approach in terms of the physical layer, data link layer, and network layers. As I said, AI tasks can be classified like clustering, classification, regulation, and prediction and decision makings. There are same functions in the physical layer, data link, and network layer. I summarizing this. Let's say the signal detection and symbol detection is we can see this kind of a function is regarded as a clustering. So likewise, there are many different functions is overlapping. So the AI technique will be improved. Could have the first one is we have the current AI blocks, and we including the AI block is additionally. Then we're gonna compare that outcome. Then we bring some more optimized outcome we can have. This is one approach. Let's say when we have a signal constellation that was fixed at the moment, but if we're using that AI technique, we can tweak the constellation, the location, so the more clusterized, then we can have the better performance using this kind of approach. Second approach in the physical layer is we combine the two different types of AI and the physical layer functions. As you can see here is AI function block here, and the physical layer function blocks here. So using the two different types of outcome, then we can create the new outcomes like a YI using the X and the delta. That's the thing I can do. Third approach is we combine the two different algorithms. In the physical layer, bit-to-bit decoding is one of the common algorithms we are now using. But the bit-to-bit algorithm is based on the dynamic program. Dynamic program is basically AI algorithms. We are combining conflicted two different algorithms and developed something new. This is another approach in physical layer. Next one is about the data link layer. Data link function is the many functions we can do. Let's say the resource allocation, scheduling, adaptive max, and data aggregation, and the value detections, and interface detection, and so handover. There are many functions. They are basically in line with AI functions. So there are many approaches we can do. I can't tell everything, but just to pick up only one thing. So let's say this one. Data-driven resource allocation and scheduling. This is resource allocation and scheduling. Basically, it will enable the resource allocation function to have the learning ability, adaptive, and optimize the channel conditions. That's the thing we can do. So AI basically in line with the physical layer, the network layer, data link layers, and can improve the performance. Likewise, network layer, they have multiple functions like a traffic prediction and classification, routing, optimal routing paths and queue management, port detection and queue management. That can be also to improve the network functions using the AI techniques. So I just summarizing this table. Okay, next one is about the ecosystem of the 6G and AI and vertical. So first of all, I will briefly introduce the European 5G PPP program. So in the European 5G PPP program is composed of the 3 phases. Phase 1 is the developing the key technique. Phase 2 is the developing the performing the proof of concept. Phase 3 is perform the large-scale trial. So the European Commission invested over 200 million euro for the 5G PPP phase 3. So in 5G PPP phase 3, European Commission selected the 10 R&D projects. This 5G hard is one of them. So our mission is to perform the 5G vertical trial in large scale. So we are covering the aquaculture, and also automotive and transportation and e-health. And other R&D program is covering the different area, let's say the energy or media and smart city, public safety, and so on. So the as I said, the 5G hard is the one by CT 19 projects of the R&D consortium. So we are granted 40 million euro from European Commission. These projects ended last year. So if you have more interested, then you can visit the 5G.org, this project website. You can download it and watch the video clips a lot. So our partner is about 22 partners. We are spreading the whole Europe. So we have the many R&D groups, research center and university and the big company and small company and local authority we have. So we are covering 3 different verticals, the healthcare, aquaculture, and transportations. So I will talk about a little bit more detail about next slide. So this is a big R&D facilities. We have the big R&D facility for the validate the 5G techniques. So in Oslo, in Norway, so UK, that's in Greece, and all of Finland, and Groningen in the Netherlands. We are using this pilot test and R&D facility. First of all, aquacultures have so many pain points. So many people think so the fish farming is just the building the net and the feeding and that's it. But it's not that simple. So there are many pain points in the aquaculture industry in order to overcome and to improve the production performance. Then we are using the 5G and AI technique. So what you can do using the sensing camera and the drone and edge computing. So we are deploying this system into that, and then we are improving the network aquaculture performance. So this is the actual fish farming we are deployed in the Norway side. So I will show you the more details about the next slide. So in these user cases, we are performing the 5 main user cases. First use case is about sensory data monitoring, camera data monitoring, automation and actual functionality, edge and cloud-based computing, cage-to-cage on-site communications. So using these user cases, we are monitoring the fish farm. This is the actual fish farm we are using. This is Assen side, Greece fish farm. This is Norway side, Trondheim, located. Trondheim, the fish farms we are using. So let me show you the first video clips about our demonstrations. So hopefully you can see this well. Okay, this is aquaculture monitoring systems we are deployed. Very simply talking about the network communication. We are installed camera and sensory data, the fish pump under the camera. Then that kind of data is transmitted to the local data center through the 5G networks. In the data center, we are receiving high quality data and detecting and monitoring the aquacultures. In this video clip, is detecting the pellet. So if your fish farmer is give some pit, then we can detect this kind of things. We are using the AI algorithm, obviously CNN, and we are detecting the pellet. So in these use cases, we know how much the fish pump should be paid to the fishes. So when we feeding, the kind of scale will be detected. So if you go to a little bit more, then there is see, as you can see here. So the many pellet is the AI algorithm can be detected. See, then the fish will eat pellet, and that this pellet detection is decreasing. So what it can learn from these use cases, how much they're gonna eat in the fish farm. That's what it can do. Okay. So next video clips will be about the more general aquaculture monitoring system.
Fish farming is the world's fastest growing food producing sector, employing thousands of people in many countries and generating billions of dollars in revenue in local economies. The salmon farming industry alone is now producing more than 17 billion meals every year. Some of the major challenges in fish farming have grown for the industry and still remain to be solved. At 1.6 million metric tons of raw material going into salmon feed every year, almost 10% is wasted. Better monitored and efficient feeding would reduce the spill of feed going into the marine ecosystem. Although quite inaccurate, physical sampling of fish and manual observations of the surrounding conditions have been the most frequently used methods to indicate fish welfare. Today, the fish farming industry has started to realize the advantages that technology can bring into the business. New technologies such as environmental sensors, high-quality imaging, and software analysis open up for a range of solutions to better monitor the health and welfare of the fish farming industry.
We are using.
State-of-the-art high-quality cameras provide sharper images that will enable a more efficient control in each of the tanks.
This is a kind of machine learning detecting the fishes.
High-quality underwater videos to monitor the fish as well as the environment and eventually automate feeding. However, taking advantage of these features requires a superior transmission capacity which is beyond 4G's capabilities. Therefore, we need 5G to transmit massive video and sensor data streams from the fish farm to the cloud and/or edge for analysis, enhancing decision support, remote control, and monitoring processes in the industry. In this respect, 5G Heart will leverage 5G Venice Norway facility in demonstrating the aquaculture use case scenarios in the Norwegian pilot.
Okay, thank you. And next, this is basically the system configuration as you can see here. So in the fish farm and the edge, they are located this kind of document that data will go through to the data center using the 5G network configurations. Okay, then next about the healthcare industry. Healthcare is very good match with the 5G and AI technique. So there are many pain points. So we're gonna overcome this kind of things. So what it can do is to mainly we are covering the four main different things before the hospital, in the hospital, and after the hospitals, then we can take care of the patients using the 5G and AI technique. So we have many different types of use cases. So first one is educational surgery. So the medical doctor, med student will be helpful for using this kind of technique. So they could observe in the surgery rooms how the doctors operating, so they could learn more efficiently. The other thing is the pill cams. I will show you more details about the pill cams. So if you swallow this pill cam and then we the recording our stool, that the kind of things we have done, and vital patch, and also ultrasound the video and parametric support, and so on. So now I will show you, this is three main different types of categories. So remote interventional support, remotely we can observe the patients. This is the actual demonstration. This is robot arm, and locally, remotely we can control this robot arm and the monitor and observing the patient. That's the thing. The other thing is the pill cams. This is the actual side of pill cam. That kind of data is transmitted outside the storage. That will be then we're gonna analyze that. So this is old version. So we have to much eliminate this kind of storage because this is very heavy and takes quite a long time. So what you can do is to swallowing the pill cam and transmit data to the outside the transmitter, and that transmitter is directly send that data to the data center. Then in the real times, AI algorithm is detecting whether or not there is polyp or cancers. So that's the thing we can do. I will explain a little bit more detail about pill cam. Then the vital patch, this is the actual size of the patch. If you attach this kind of patch and remotely we can monitor the patient's health conditions. So, okay, then then I will very briefly show you about the healthcare particle trial.
Digital technologies such as 5G mobile communication, artificial intelligence, and supercomputing offer new opportunities to transform the way we receive and provide health and care services. The research on e-health in 5G Heart is targeting the vision of enabling a hospital without walls. The 5G Heart project has explored this vision through three major use cases: remote interventional support, colon capsule for early anomaly detection, and remote monitoring of patients and workers with advanced geolocation. The remote interventional use case has explored four different scenarios: educational surgery, where advanced 5G technology with real-time video can extend the in-hospital coverage and enable faster reaction time for primary treatment, as well as novel and safer ways for consulting and education. Remote ultrasound, where 5G technology is used to perform remote-assisted ultrasound examination targeting newborn babies with suspected heart conditions, and robotic ultrasound, where full control of the examination can be given to an expert located at a remote hospital. Paramedic support, where we have tested how lightweight wearable video cameras over 5G can provide better information from ambulance personnel to the dispatch center and emergency ward. Urban search and rescue, where a scene commander can be given a better situation overview by having the rescue workers use wearable video over 5G. In the colon capsule use case, the project has developed and tested how a pill with an integrated camera can replace colonoscopy to diagnose colon cancer in an early stage. By connecting the capsule directly to the hospital cloud over 5G, the video from the colon can be analyzed in real time using deep learning-based artificial intelligence algorithm to instruct the capsule to perform deeper inspections of suspicious areas. Remote monitoring is an IoT use case which targets both patients and workers with a need for real-time monitoring of the health conditions. By applying a small, unobtrusively worn sensor device, we could shorten hospital stays while continuing to monitor patients at home for up to 30 days, improving outcomes, reducing costs, and improving the patient's experience. By adding geolocation realized with low-power, wide-area connectivity to the patch, we can localize the patient for emergency services to effectively assign resources at the right location. We have also explored a case where aquaculture workers are offered a solution with remote, real-time, and predictive health monitoring, including reliable notifications to healthcare professionals or supervisors and live video streaming in case of a health incident or health emergency prediction. 5G and e-health is the perfect match. 5G can provide the connectivity to enable a new health ecosystem. 5G could transform and improve all critical components of health. 5G can support the transformation of the healthcare sector from volume-based to value-based care. 5G is essential to build the digital base in healthcare, and 5G can provide network security and data privacy, which are paramount for healthcare. By exploring e-health scenarios covering different stages in health treatment and services, 5G Heart has demonstrated the benefits of using 5G to bring healthcare out of the hospital and to the patient.
All right. Okay, this is very general. The healthcare use cases we developed so far. So I will deep dive a little bit more about automotive, the pill camera. So as you can see here, so the patients will swallow that the pill cam and detecting the polyps inside our body. So the next video is about the pill cam.
Cloud solution.
Sorry about that.
Okay. So here is a pill camera. The pill camera, as you see it here, that will be having LED lights on both sides, and also in future it will be having two cameras at both ends, and a microcontroller, and node transmitters.
This gentleman is the Professor Lanko. He is in the Oslo University Hospital.
And then the idea is that you can swallow this pill, and then the pill is going through the big bowel, and then it will be transmitting video from there. The idea is that using this video, we would be able to see how the bowel looks like and whether it has any anomalies. Like, for example, polyps, like small mushroom shape tissue structures potentially can become cancer in the future. So we are very much interested to see whether we can detect polyps using this pill camera, and then to transmit the video using a recorder belt. And this recorder belt will be integrated with a modem, as you see here. So in the future, you don't need to have a big modem like this, external one, but here in this project 5G Heart, we have borrowed this modem to demonstrate that we can use the video using the modem, transmitting the video to a cloud solution where we have implemented AI algorithms so that we can, in real time, we can detect polyps. Here in this picture here, as you see, you have polyps. These are small mushroom shaped structures. And in the second one that you are seeing is the first one was streaming the video using the 5G modem to a cloud. And then the results are displayed here in real time. So in the future, what we can do is that we can stream this video while the pill is moving inside. And then we can optimize the camera parameters like number of pixels per frame and number of frames per second, and also the lighting. And in this way, we would be able not only to detect polyps, but also to do classification. So the first, of course, polyp detection is important. The second part is whether this polyp is dangerous or not. For example, whether it has become cancer, we cannot do so much with that. But if it is in the class between normal polyp and adenomas, then we are very much interested to see whether this could be removed before it becomes cancerous. So here we can show you this. Okay? To demonstrate the concept, now we have a video file from the inside camera. So this is actually a video file of the colon that is being streamed using this pill. And here instead of, we don't have that we cannot do it inside a human body, so we have simulated the human body using this phantom here. So, and as you see here, you have the pill, and the video file would be streamed using these two electrodes there. And then when we put this inside, then with the liquid and the container here, pretty much simulating the human body. And then, and this antennas that is placed is to be part of the recorder belt that everyone will be using in the future. So you just wear it like a belt outside, but these external antennas will be sending signals to the pill. And since the pill does not have any batteries for transmission, it does have any active transmitter. So in this way, we can save both battery power and also space in the capsule. So capsule becomes much simpler. And then the signals goes through this box here, as you see here. It contains quite sophisticated electronics to decode this information from the pill, and then display this decoded information on a computer there. So we show you, for example, the whole day, for example, when it comes from the pill to external computer that could be decoding the video signals. And in the future, we can transmit them using the 5G modem to a cloud solution. So the whole process is that, as you see it here, so we have the video coming from the pill camera, and as you see that from the polyp here, hopefully the AI is able to detect the polyp in real time, send information back to the pill, and then it will be able to improve the camera parameters like resolution, frame rate, and also lighting of this pill. And in this way, we can have a solution where a user uses everything by himself or herself, and the whole solution will be automatically analyzed and detected, and then the report will be sent to the physician or to the patient.
Okay, thank you. Thank you. And this is one example of the automotive pill cameras. So this is a good example of combining the 5G techniques and also the AI technique. So next is about the transportation. Vertical transportation is also the good important the verticals we can utilize adopting the 6G techniques and AI technique. So there are four main transportation verticals we have: this flattening, autonomous assisted driving, remote driving, and the vehicle nature services, and so on. So first things I want to show you about the general the 5G transportation use cases. Next one I will show you a little bit more details.
Communication between the vehicles, infrastructure, cloud, and other road users is crucial to increase the safety of future automated vehicles and their full integration in the overall transport system. 5G is expected to meet the requirements of various advanced use cases of the transport vertical through enhanced wireless connectivity and increased automation. The transport vertical trials in the 5G Heart project are structured under 4 high-level use case categories, which study the capability of current 5G technologies to support vehicle platooning, automated and assisted driving, remote driving, and vehicle data services. Support for platooning is investigated in one main trial scenario. High bandwidth in-vehicle situational awareness and see-through for platooning focuses on providing a high-definition video stream from the platoon leader to the other platoon members. Support for automated and assisted driving is investigated in 3 trial scenarios. Smart junctions and network-assisted and cooperative collision avoidance provide safety information to vehicles to prevent traffic accidents and assist cooperative automated driving functions when vehicles pass through an intersection. Quality of service for advanced driving trials a computation offloading scenario that enables an automated vehicle to maintain a higher level of automation in situations where it was not originally designed to operate. Human tachograph service utilizes wearable sensors to monitor the driving conditions of professional drivers and triggers anonymized warning messages towards other road users in case of increased risk. Support for remote driving is investigated in one main trial scenario. Teleoperated support involves a remote human operator sending control commands to the vehicle and receiving information on the vehicle state and its surroundings over a 5G network. Support for vehicle data services is investigated in 7 trial scenarios. Vehicle prognostics trials focus on fast upload of vehicle status information, while over-the-air updates trials study data download over 5G links. Smart Traffic Corridor Service utilizes air quality sensors and vehicle emissions data for vehicle route optimization, and location-based advertising uses vehicle, passenger, and location information to tailor content stream to different vehicles in the area. End-to-end slicing demonstrates network slicing as a service capability via dynamic orchestration and deployment of network resources to support the various use cases of the transport vertical. Vehicle-sourced high-definition mapping and environment services rely on a crowdsourcing approach to collect highly localized data from various onboard sensors in vehicles and use it to update a central service running in the network. Through this extensive set of trial scenarios, the 5G Heart project has been able to verify the capabilities of the current 5G technologies to serve the specific needs of the transport vertical.
All right. So this is a very general introduction about the transportation vertical trials. As I said, performed multiple over 10. The use case scenario has been performed. So one of them is human tachography. So I will show you the next video. It's about human tachography.
The human tachograph service is tracking the live biosignals of professional drivers. The service also tracks the driver's sleep and physical activity in long term. The combination of real-time and historical data enables more accurate assessment of current driver condition. The service is fully based on wearable sensors and do not require modifications to existing vehicles. Using 5G connectivity, the warnings generated by the human tachograph service can also be shared with other drivers, automated vehicles, and road safety systems. The human tachograph trials have 2 main objectives. First, to validate the 5G uplink performance for reliable real-time monitoring of drivers' ability to drive. Second, to validate the 5G downlink performance for distributing warning messages to other road users based on the identified risks. For cooperative collision avoidance scenarios, the 5G network must be able to provide 10 millisecond end-to-end latency and 99.99% reliability for the human tachograph service. The latency target can already be reached with current commercially available 5G equipment. The reliability target cannot be fully reached and requires further enhancements in the 5G network. The validated performance of the current enhanced mobile broadband 5G technologies are already able to partially fulfill the communication requirements of the human tachograph service. However, ultra-reliable, low-latency communication enhancements are still needed to reach the required end-to-end latency performance with the required reliability.
Okay, then this is a very short introduction about human tachography. The next one is the teleoperated support. This is a kind of remote driving. So when there is a vehicle and remotely we can control the vehicle. So we demonstrated this one.
Remote driving and teleoperation refer to the remote control of a vehicle using the available mobile network infrastructure. Teleoperation can serve as an intermediate step for realizing the broader vision of pure automation. Most importantly, though, it can assist in providing the required advanced safety level to autonomous driving technology as an additional service. The 5G Heart project realized the design, development, and validation of a teleoperated support service over 5G mobile communications. More specifically, a fully functional teleoperated support service prototype was developed from scratch. The prototype emphasized the end-to-end application architecture and the type of data transferred between the vehicle and the remote operations center. The performance of the developed service prototype when used over 5G mobile communications was assessed under realistic conditions by numerically evaluating the achieved one-way latency, jitter, throughput, and data loss rate. The Remote Operations Center serves as an interface with the human operator. The onboard unit interfaces with the sensors, cameras, and the actuators of the vehicle. The Remote Operations Center gateway acts as an intermediate communication point between the vehicle and the Remote Operations Center. The 5G network infrastructure is responsible for realizing the communications between the Remote Operations Center and the vehicle. In the field trials, a research vehicle properly equipped with the sensors and actuators was remotely controlled from a distance of around 36 kilometers. The vehicle's velocity was up to 25 kilometers per hour, and the distance between the 5G base station and vehicle varied from 60 to 120 meters. Approximately 500 minutes of raw measurements and video recordings were collected from the trials while conducting the following maneuvering scenarios: straight maneuver, turn right maneuver, lane change maneuver, and parking maneuver. Measurements capturing the outgoing and incoming data traffic were performed from multiple points in the 5G uplink and downlink data paths connecting the Remote Operations Center and the vehicle. The collected measurement data was analyzed to calculate the achieved latency, jitter, throughput, and packet loss performance, and to assess the effectiveness and efficiency of the 5G network infrastructure in supporting the teleoperated support service. The trials showed that teleoperated support with 5G is feasible at low speeds, even in complex tasks. Communication latencies need to be further reduced and data throughput improved to allow for scenarios at higher velocities. Empirically, the achieved latency values were sufficient for controlling the vehicle during the conducted trials without any issues. In practice, there is a certain degree of freedom available for the operator, who can adjust the compression level until reaching the desired balance between the uplink throughput and image quality at the Remote Operations Center graphical user interface.
All right, thank you. So, okay, this is about our transportation vertical use cases. Next one is also you'll have. Oh, yeah. So I think this is all my presentation. So I showed you about the many use cases, scenario, and demonstrations. But they all use case scenario is not individual use cases. Basically, we consider the one big scenario, then each of them are part of the whole scenario. For example, we can consider when drivers, we can imagine this kind of scenario. Think about that. one drivers have during the driving got some strokes or sleepy or something, and that he could not drive anymore. In this case, the car accidents happened. It will be disaster. It is the big problem in normal situation. But we can help. You can improve these situations. For example, if someone got some stroke, then we can detect the kind of dangerous situations, and then we can react. Using the human tachography, then we can detect the driver's health conditions, whether or not he can drive. In the data center, if this is a very dangerous situation, he could not drive anymore, then we can switch it drive to the autonomously or the remote driving. After that, the more important thing is to bring this patient to the local hospital as soon as possible. This is lifetime matter. So that we can control the traffic lights using our 5G slicing technique. So each of the use case scenario has been developed in this project. This is one whole scenario. So if you are interested in more use case scenario, you can visit this project website and the YouTube channel like this. Okay, I think this is all. Thank you. Thank you very much for attending my talks. Thank you.
Thank you. Yeah. Thank you, Dr. Kim. Thank you very much. And I can understand the amount of work that has been gone behind this presentation. I hope the audience here must have got a glimpse of what the 5G technology is doing in terms of transports, in terms of healthcare, in terms of the body parameter measurements, colon health, heart, and whatnot actually. So it gives us I must say that this 45-minute presentation is almost a work of a decade, and he put it all together and presented in this case, and he has shared all the links. He has also shared the YouTube links. He shared his lab page, and I think you should be all of us should be going through that. And all these technology, remind you, all these technologies are quite new, quite advanced, and even in some of we don't have many of them in India actually. So at Finland, they are doing a great job. And in this case, I find that this talk is very interesting, very future looking. Actually, it's advanced, it's future looking also, and it gives us an idea about what we can do with 5G. With 5G kind of a communication. And India, you know that recently 5G has been launched. So it gives us a glimpse of what we should be aiming at, or what is there in India in the coming decade actually. So thank you very much, Dr. Kim, and I request the audience to, if you have any questions, please direct to me, and I ensure you that it will go back to Kim, and I'll get back his answers. It is still very early morning, around 4 a.m. at Finland. And he just sent me a message that he just got up, but he will not be able to be online. Thank you very much, Dr. Kim, and over to you all.
Thank you, sir. Now I request Professor Mian to take over the charge of the sessions as a session chair. Professor Bhuya is working as the professor at University of Malaya, and he's also a good researcher. Now he will take out the charge of this session. Please, sir.
Thank you very much to the organizer to give a chance to have chair the session. So now the next speaker is Professor Xiaoji Zhao, University East Finland. He's professor in the School of Computing, University of East Finland, and he's also acting head of Inspired Machine Learning and Research Group of UEF. And his research mostly on bio-inspired computing and nature computing, machine learning, big data analysis, soft computing, data mining, and communication network. He has published more than 400 papers in different international journals, and also many reputed conference, has participated, also chair in many editorial board members. So it's a very pleasure for us to have to look at his work at the present and also explore our knowledge along too. So now welcome Dr. Xiaoji Zhao to present his work. Thank you. Is there any technical issue?
Just a wait, Professor Bhuya, it will.
Hello, everybody. My name is Xiaozhi Gao. I'm a professor of School of Computing, University of Eastern Finland. I'm very happy to deliver a talk entitled Nature-Inspired Computing Methods and Applications. It's a great pleasure for me. My presentation today will be rather brief. I will first present the concepts of nature-inspired computing methods, what they are and where they come from. And after that, there will be some examples about the applications of nature-inspired computing methods. Later in the presentation, I will also explain some of our own work in the nature-inspired computing methods. Okay, so the first thing first, what are nature-inspired computing methods? Basically speaking, the nature-inspired computing methods are based on the principles of how the nature works, meaning that we can learn a lot from the nature, and we can develop the algorithms to mimic how the nature works. We learn a lot from the nature. In general, the nature-inspired computing methods consist of a few kinds of techniques. For example, swarm intelligence, neural networks, genetic algorithms, fuzzy systems, artificial immune systems, and etc. The list is much longer than the one I put here. So let me use the swarm intelligence to explain how the nature-inspired computing methods are derived. As we know, in nature, a lot of species like insects, animals, whatever, they live in swarms. In other words, they live in groups. They are also social creatures. For example, fish, they swim in groups. Thousands of or even millions of fish may swim in groups. In that way, they can find the food easier, and they can also avoid their enemies. Besides fish, some other species like bird, bird, they are flying also in groups, and bees especially, they can build a very complex nest. So here is a picture showing the complex structures of the nests built by the bees. You can see that from the outside is quite a natural. It looks quite simple, but if you cut it, and you can see that the bees nest actually has different floors, and it shows a very complex structure. And also, like this picture, it shows another bee's nest. So the insects like bees, ants, fish, birds, they work together. They actually show some kind of collective behaviors. And that is very important because a small bee or a small fish or ant, they are really simple and they can't do too much. But if they live and work together, if thousands of or tens of thousands of even more bees, ants, they live together and they can work together and they can do something amazing. The way they can work out is that they are able to exchange and share information. They can exchange the knowledge, and in that way, the whole group will be very powerful. Like this one, the bees can work together to build their nest, and also they can find their food in following the shortest path. I will explain this later on. So the nature-inspired computing methods are inspired by the principles of how the nature works, including the swarm. The next slide shows the flow chart of how a typical nature-inspired computing methods is derived. So firstly, there may be some natural phenomena we can observe. For example, the fish can swim in group. And by observing the natural phenomena, we get, fortunately, some perceptions. And from the perceptions, we will start to model. We can model the behaviors of the bees, for example. From modeling, from mathematical modeling, we can develop the algorithms. And those algorithms, they are called nature-inspired computing algorithms. They are kind of methods we can use to handle our own problems. So if we have some problems in the engineering fields like signal processing, control, optimization, data mining, machine learning, whatever, those nature-inspired computing methods can be applied to handle those problems. So finally, those nature-inspired computing methods are used to solve engineering problems. This is a very representative flow chart from observing the natural phenomena to using the nature-inspired computing method to solve practical problems. So by following this path, we can develop a lot of, or people have already developed a lot of nature-inspired computing techniques. Let me show you one example. For instance, we know that the ants can find they can find the shortest path connecting their nest with the food source. So the ants are walking like this way. So if there are multiple paths connecting their nest and the food source, they can always pick up the shortest one. How can they do that? People did some experiments a long time ago, and this picture shows that you can see if there are two paths, one is shorter than the other, the ants can automatically, most of those ants, they can automatically choose the shortest path. The way they can do that is, as I mentioned earlier, the ants can have some techniques they use to exchange and share the information. When the ants are taking the food from the food source to the nest, and also when they are moving from the nest to the food source, they will deposit, they will lay down some pheromones on the path, and the pheromones will guide the ants, the other ants, to follow. And by doing this, the ants will find the shortest path. So the pheromone is a kind of medium that the ants use to communicate with each other. So one ant can be very simple, but if there are so many of them and they use the pheromone to exchange the information, then the whole group will be very powerful, and they can, in this case, find the shortest path. And this is really very attractive. The procedure looks like this. So if there are, suppose if there are two paths, A and B, from their nest to the food source, A is shorter than B. At the beginning, the ants, because they don't have any knowledge about which path is shorter and which one is longer, and they will choose by chance randomly one of the two paths to go from their nest to the food source and backwards. The chance of choosing path A and the one for choosing path B will be 50 and 50. So half by half. The ant will have 50% of chance taking path A and another 50% of chance taking path B. And when the more and more ants are doing the job, they are moving from the nest to the food source and returning back. When they are repeating this, then we will find out more ants tend to choose path A rather than path B. For example, after some time, let's say 60% of the ants will choose path A and 40 of them will still choose path B. You can see that choosing path A has a higher probability than choosing path B. And when time goes on, we will see that the chance of selecting path A is becoming so big, 95%, against the chance of choosing path B, only 5%. So what does this mean? This fact tells us that the ants, they can themselves automatically find the shortest path. There is no guideline coming from outside, and there is no pure knowledge they have. At the beginning, as I said earlier, at the beginning, the ants have no idea which path is shorter. But if they work together and if they repeat the procedure, moving the food from the food source to their nest and leaving their nest for the food source, if many of them they repeat this process, then they use a kind of secret way to communicate with each other. They will share the knowledge and the information they have collected. Then they will finally find the shortest path. And this gives us the inspiration of developing a nature-inspired computing technique called ant colony optimization, ACO. This is one example of nature-inspired computing methods, the swarm intelligence. And there are also other kinds of nature-inspired computing methods. For example, neural networks. Neural networks is a kind of modeling of the human brain system. So on the left part, you can see these are those nature neuron systems. On the right part, you can see this is the artificial neural networks. The neurons in the natural nerve systems, they are modeled by the nodes in the artificial neural networks. And when those neurons, they are connected into the natural neural networks, then we can also connect the nodes inside the artificial neural networks so that we get many of them connected. So the same principle applies. The neural networks, they are considered as one kind of modeling of the natural neural networks. And genetic algorithms is also based on how the nature works. In nature, we have probably, I think everybody knows that from Charles Darwin's great book called The Origin of Species. There are two kinds of theories. Well, evolution and natural selection. The species can change. It's called evolution, and the nature selects natural selection. The nature selects only the best fitted species, and those species, if they don't fit the nature, they finally die out. And this is a picture showing how our human beings can also have the evolution. Human beings also change in the history from gorilla to modern humans. And for this kind of evolution procedure and natural selection, we developed some algorithms called genetic algorithms. Here is a flow chart for the genetic algorithms. Genetic algorithms can be applied to solve optimization problems. They can be used to design some optimal stuffs. I will show you a few examples. So nature-inspired computing methods are developed. Again, as I want to explain, they are developed based on the inspiration coming from the nature. And there are so many of them, and they have been used in a lot of application areas. In the past years, our group has been doing some relevant work. Next, there are some examples taken from our past work concerning the nature-inspired computing methods and how they are used in engineering. For example, this one, the nature-inspired computing NIC methods are used to detect faults. And the faults here, they are on the bearings. Bearings are widely used in mechanical mechanical structures. And for example, there can be some damage on the surface of the outer raceway, and also in the inner raceway, and also the balls in the bearings can get damaged. And all this can be regarded as faults. Our aim here is to apply the NIC methods to detect those faults. And this work was represented in one of our papers published in 2014. The neural networks and artificial immune systems are used in our work. Optimization, this is always an interesting topic, how to get something optimized, how to get the best stuffs. And in our work, we applied the neural networks and swarm intelligence to, for instance, to optimize these multi-peak functions. And this is taken from also a paper published 10 years ago. Anomaly detection. Here, the problem is that if there are some abnormal data samples existing, we should detect them. We should be able to detect the anomaly existing in the data samples. And we use the Fisher iris data as an example here. As we know, in the Fisher iris data, and we have three kinds of flowers: Setosa, Versicolor, and Virginica. And we consider one of them is a kind of normal data, and the other two, they belong to the anomalies. And in this way, we are using the artificial immune system, especially so-called negative selection algorithm, to detect the anomalies. And this work was published in a paper earlier. Data classification. How to classify different data samples into the correct categories. classification is not very easy. For example, here, if you are supposed to classify these spiral data samples, those circles, they belong to one category, and those crossings, stars, they belong to another category. And we used neural networks for this data classification problem. The time series classification, and this is very practical problem. We have the time series collected from real world cases, and the time series may be, for example, the chaotic time series or time series from measurement. And here, if this is a kind of normal time series and this is a abnormal time series, we have to classify them. We have to separate one from the other. And the NIC methods can be used for the time series classification. So far we have been doing work like classification, optimization for diagnosis. The most recent work focused on the prediction, power load prediction. That means we try to forecast that how much power is used concerning each user. For example, we want to know how much electricity they are going to consume in the coming days or coming weeks. And this is very important for the power generation stations. It is critical to know the future consumptions by the users so that they can easily schedule their production of electricity. And if the demand is high, they probably have to increase the generation. Otherwise, they can reduce the generation of electricity if there is not too high demand for the power. And that is also a difficult problem because there are a lot of random random elements affecting the accuracy of prediction. For example, weather, that is perhaps one of the most important factors affecting the power consumption. In wintertime, naturally the power consumption is quite high, much higher than in the summertime because people use the electricity for heating their houses. And we use the deep learning neural networks and other NIC techniques to predict the power loads for the users. And we have the results also published in a paper a few years ago. So far, I have been quickly presenting some NIC methods and also their applications. The current research work from our group actually is about the fusion of NIC methods. That means we try to combine them together. Now here you can see that we have several NIC techniques, and we want to merge them together. We can combine 2 of them or 3 of them or even more, and then we get the fusion of NIC methods. The fusion of NIC methods is better, at least it's supposed to be better than the individual NIC methods. Individual NIC methods may have their drawbacks, advantages and disadvantages. And if you combine some of them together, you may get a better performance. One example taken from our work is so-called harmony search. I'm not going to tell you too many details about harmony search. It is another NIC technique inspired by the way how musicians compose harmonies. And here, this is how a musician creates the harmony in his brain. And this is how the harmony search method can be used to solve the optimization problems. And harmony search has been used to optimize a lot of application case study, and we have done some work on this. Especially, we combine the harmony search with other NIC methods. So we have developed some hybrid harmony search methods. So if this is the harmony search method, and there are also some other NIC techniques like this B foraging algorithm, this opposition-based learning OBL, and also population-based incremental learning PBIL. And we combine, we merge those NIC methods together with the harmony search, and we have developed a lot of hybrid harmony search method. For example, if we combine the OBL together with the harmony search, then we get so-called HS-OBL, and it has been used to optimize electrical machines, like in this picture. Here, we are supposed to design an optimal electrical machine, and there are some parameters we need to find the optimal values for them. Some parameters are look like this. For example, this stator yoke height, stator outer diameter, stator slot height, and here are those symbols and also the range of those parameters. We want to find the optimal, the best values for those parameters, so that we will design a optimal electrical machine. Here, the electrical machine is a wind generator, and the results are pretty interesting. We use the original harmony search without any modification made, and also we used a hybrid harmony search called dual harmony search, and we compare these two techniques in the optimal design of the wind generator. So we want to reduce the cost of making the wind generator. The lower the cost is, the better, and we always target at the lowest cost. But interestingly, the hybrid harmony search dual HS can provide us with the lower cost than the original HS. For example, here is how the cost can be obtained by using the HS, and this is the cost from the dual HS. You can see that this one is smaller than this one. Not a very big difference, but still this is in terms of euros, because we are talking about the price of making the wind generator. And still a small difference will actually make a big profit, especially when the company is going to manufacture a lot of them. Even you save 1 penny, you can get a lot of profits, because the amount of the machines is quite huge, thousands of them or even more. So I briefly present some of our past work on the development of NIC methods and also their applications. Our current work is from this project called the BioColor project. In this project, people are using the nitro. People are studying the nitro colors for dyeing, and for dyeing, like for example, clothes, medicine, prints, whatever, and people are interested in the natural colors rather than the artificial colors. This project provides us a very interesting opportunity to apply our NIC methods to solve some data mining and machine learning problems. Next, there will be some slides showing showing our master's degree students' work. Like for example, here, one master's degree student, Shi Cheng, he did some work by using a traditional classification technique called nearest neighborhood KNN SVM, support vector machines and also neural networks. He compared these three classifiers, and the results are like the neural networks, they can provide us with a slightly better classification result. And Zongyue Li did some work of clustering. So classification is like this and clustering is like this. Their work is based on the data samples from this project. The project gives us a lot of data samples, and we can, for example, study the classification of those data samples or clustering of those data samples. Zongyue Li did some work in clustering, so how the data samples can be clustered. They are grouped, similar data samples are grouped together into a single cluster. And Yabra did some similarly, he did some work on the clustering, but he used a Firefly and the Cocoa search. These two nature-inspired computing methods are used to give us the optimal clustering results. And he compared these two techniques with the classical clustering technique K-means. And naturally, the NIC methods can always optimize the clustering results. Deep learning is a quite a popular topic these days. For this, we also have some students doing the work, like Merlin, she did some work using the deep learning neural networks for classification. So here, like this is a picture of flower, and by applying the deep learning neural networks, finally, this picture is classified into one of the two categories here. One issue is that we actually sometimes don't have enough data samples. The number of the images can be rather small, and Merlin also applied, besides the deep learning, she also applied the data augmentation technique to artificially generate more data samples like this one. So when you have the original image, by like flipping and rotating or whatever, shifting, you can also get some other images. And those images produced in this way, they are called augmented data samples. And those images together with the original images, we can have a much larger data base. And she used the data augmentation together with the deep learning, and the results are rather promising and encouraging. So this is our current research work in this so-called BioColor project. We are using the state-of-the-art data mining and machine learning techniques, especially deep learning. And now I want to draw some conclusions to conclude my talk. In the talk, I just quickly and briefly went through the fundamentals of nature-inspired computing methods, particularly how they are derived and how they are inspired by the nature. Basically, the nature-inspired computing methods are very remarkable and powerful solutions. They are quite often they are better solutions than the conventional techniques. For example, in data mining, in machine learning, and the fusion of the nature-inspired campaign measures can be a topic for us to explore in the coming years, how to study the combination of different NIC techniques and how they can outperform the other individual NIC techniques. This would be an important but also difficult topic for us. For example, if you want to combine the swarm intelligence with deep learning, that seems to be quite interesting topic. All right, I believe I can stop here, and I give the floor back to the chair. Thank you so much for your attention.
Okay, thank you very much, Professor Jiaoji Ngo. So it's a very nice presentation based on the computing and combining nature and inspired computing and machine learning, big data analysis, also give hints about the neural network and Bayesian analysis. So on these topics that you have using there is also very nice presentation for your NIC method of optimization. So it's inspiring to do many calculations based on that method. So now it is welcome to all the audience to have any open questions for him. So you can raise your hands for that.
Yeah, Professor Bhuiyan, you can close the session. We'll take the questions offline.
Okay. Okay, then we have, you can write your message to be there and the questions for the next person. So now we can stop the close sessions for the present one. Okay, thank you very much, Professor Jiao again.
Okay, thank you, Professor Bhuiyan. I request Professor Ramesh to run the video and start the next session for this your Professor Ghania. ಯಾವುದು ರಮೇಶ್ ಅಂತ ತಿಳ್ಕೊಂಡು So,
good morning, ladies and gentlemen. Thank you very much for attending my keynote, which is entitled Mars Media and IoT, a natural combination. I'm pretty sure most of you know what IoT is. I'm not that sure you know what Mars Media is, but hopefully you will be very shortly. So my name is George Guignard. I'm a professor in the Department of Computer Science at Brunel University in London. The university has two distinguishing characteristics as opposed to most of the other universities in the UK. Good morning, ladies and gentlemen. Thank you very much for attending my keynote, which is entitled Mars Media and IoT, a natural combination. I'm pretty sure most of you know what IoT is. I'm not that sure you know what Marsi Media is, but hopefully you will be very shortly. So my name is George Guignard. I'm a professor in the Department of Computer Science at Brunel University in London. University has two distinguishing characteristics as opposed to most of the other universities in the UK. The first characteristics is that for a large London-based university, which we are actually a campus-based university. Of course, land and real estate is very expensive in London, and most other London universities, they are not campus-based universities. They have a building here, a building there, scattered throughout London. We are actually on the outskirts of London, but still within Greater London, quite close to Heathrow Airport. So the logistics of international visitors coming to us are very good. And we are a medium-sized universities by UK standards, roughly 15,000 students, a third of which are postgraduate students, being both masters and PhD, as well as roughly 2,500 staff supporting them. Well, that was, and here you have a typical sunny day in the UK and pictured on our campus. So on our Unitary campus, located in Uxbridge, very close to Heathrow Airport, as I was saying. Another distinguishing feature is that as opposed to most other British universities, which are named after the location in which they are situated, University of Oxford, of Reading, of Cambridge, of Nottingham, of Birmingham, of Cardiff, of Edinburgh, and so on. We are not named after the place where we are situated. We are not named the University of Uxbridge. We are named after a person, and that person is actually an engineer, and his name is Eisenberg Kingdom Brunel. And he was a Victorian engineer who put the basis of the Industrial Revolution in the UK in the 19th century. So of course that shows that our heritage is engineering, and when we were formed as a university around 50 years ago, engineering was one of the main activities of our universities. Here, of course, there are all sorts of statistics which come out all of the time, and of course each university tries to draw the attention to those which do them justice and do them proud. We are particularly proud that in respect of new universities, we are doing quite well. As you see over there, we are ranked 35th in the world and 6th in the UK. However, whereas that is from a university point of view, from a departmental point of view, computer science, the department of which I'm part, is actually quite well regarded in the United Kingdom, because in terms of our citation quality and quantity, so these are the number of citations gathered by the publication that we write as a department, as well as, of course, their quality as well. If you have this combined metric, we are actually 5th in the UK. So it's again something which we are particularly proud of. So without further ado, let us start this very controversial statement that computer science can be magical. Well, what do we think when we think of something being magic? Well, we think of something that, look, is so counterintuitive, so but at the same time wonderful, that it really cannot be true. There is no logical explanation for it. It's totally illogical, but it's nonetheless it is counterintuitive and wonderful, and that amazes us all the time. Well, these two gentlemen pictured here, they are the closest thing that I think that computer science has actually ever come to creating magic. Why? These two gentlemen are, their names are Diffie and Herman, and they are both American mathematicians, and around 45 years ago, they put the basis of a famous algorithm which bears their name. And essentially, it says the following. It says, if I'm in the UK and I want to communicate in a secret and secure manner with someone in India, well, I don't need to meet that person in India beforehand in order to agree a secret shared key, which only ourselves know, in order to communicate. What these gentlemen did, basically, they came up with a famous algorithm which bears their name, the Diffie-Hellman algorithm, which showed how two distinct communicating parties can construct a secret shared key over an insecure channel. So it's a step-by-step recipe for two parties which have never ever met. They can be at different sides of the world, to construct a secret shared key. So the algorithm is known, the channel, the internet over which this secret construction of the secret shared key is being done is again insecure, so everybody can snoop, yet the key itself is secret. So it's so counterintuitive, that how can I construct something which is secret over a channel which is prone to eavesdropping and snooping by everybody? It's so counterintuitive, it's magic. Of course, as opposed to actual magic, where there is trickery involved, this particular algorithm, there is no trickery involved. It is mathematically provable. You need higher order algebra to understand the proof. But even if you don't understand the proof, the effect of the algorithm is, you will agree with me, as close to magic as computer science and indeed engineering could come. And of course, we as researchers, we do want to replicate magic in our work. We like it when we get some magical, amazing results, and hopefully, each one of us does this at least once in their career as a researcher. Point I'm trying to make, and again it's a bit controversial, is that multimedia is not actual fact multimedia. And what do I mean by this? Well, I mean by the fact that, if you think about the word multimedia, what does that imply? If I ask you what is multimedia, you tell me immediately, multimedia is this, multimedia is that. Well, the word multimedia has is obviously made up of two words, multi and media, multiple media, and it sort of conjures up the image that multimedia presentations are those which involve multiple media. Now, even if you're thinking now of this particular presentation that I am now giving, what are the media actually that we are talking about? Well, it's the audio and my voice and the video. So really, it's not exactly multiple media, it's two media. It's multiple media, of course, multimedia is a very, attractive marketing term, to gain market share. And from that point of view, multimedia applications have been incredibly successful. But really, we're talking about two media. So it's not really, strictly speaking, multimedia, it's bimedia. However, you will tell me, but hang on a second, we are talking, you have forgotten, conveniently perhaps, to talk about text, the textual media. And yes, that is true, okay? There are three types of media involved. However, we are still involving only 2 out of our 5 Aristotelian senses, the sense of vision and the sense of audition. Whereas the other 3 senses of olfaction, of haptics, of gustation are not involved at all in a digital world. And this is why a few years ago I came up with this new term called multimedia, which stands for multiple sensory media. And I define it as being those applications which involve in a digital context at least 3 of our senses. So you cannot just have 2 of the traditional auditory and visual senses, you have to have at least one extra sense on top of that in a digital context. By the way, at the bottom of each slide are the relevant papers in which those concepts or those results have been published, and they'll also be available at the end in bibliography. So I came up with this, a new word called multimedia. Now, of course, this new multimedia, these type of multisensory devices have been around for quite some while. Oddly enough, you're thinking of things like smell-o-vision and about 3D, 4D, 5D applications in various theme parks and so on. But just like before, when you had when you wanted to go for a true cinematic experience, you had to go to the actual cinema, and nowadays people actually have home cinemas in the comfort of their own domestic setting to experience, brilliant audio and visual quality. The same thing is happening over here, because whereas before you had all of those niche type of applications, which were multisensory and very in theme parks and a lot. Now these type of applications have been brought to the comfort to more domestic and more non-niche specialized settings, and these have been enabled by a proliferation of multisensory devices. And what type of devices am I talking about? Well, we have here a humble air fan, of course, which generates airflow, and the air touches our skin and increases our sense of immersion, of experiencing the particular content. Here, ladies and gentlemen, this is an olfaction device. This is a device which is USB controlled. It has 4 fans. Behind each fan lies a scent, and then each scent is emitted into the atmosphere by that fan switching on. And you can control not only when you switch on the fan, but when you switch it off. You can control which fan you switch off out of the 4. You can control 1, 2, 3. You can have 1, 2, 3, or 4 fans, or emitting scents at the atmosphere at the same time. You can also control the rotational intensity of each fan. So again, this device, programmable via a USB controller, is one to which we can emit olfactory scents and olfactory stimuli into the atmosphere. Last but not least, we have this gaming vest, ladies and gentlemen, where if you're playing the game, and you get hit or you get shot, that whole vest will vibrate and will give you an added sense of participation, of immersion in a particular game. But indeed, this
Hello? Hello? Any issue?
about multi-sensory displays, this is another one, and here you might be a bit confused, okay, because obviously you can see that the person is actually wearing a head-mounted display, so she's obviously experiencing something in virtual reality. However, what exactly is that person holding in her hands? Well, perhaps if I go to the next, that receptacle slots into the HMD at the bottom of the HMD, and now perhaps it becomes a bit clearer, ladies and gentlemen, that this receptacle actually holds two devices. One which is a fan which emits air and which of course is all to do with haptic devices, but the other one is that there's another fan which emits olfactory device, which emits aromas. And of course it makes sense to have this type of device all wired on the person's head, because if you think about it, all of the 5 senses are concentrated around a person's head. So the eyes, the ears, the nose, the tongue, as well as the skin. All right. So of course that is where a person experiences multisensory interaction in its most pregnant form. Having said that, imitation is was telling you about all of these devices being interconnected. So we wrote this paper, the details of which were actually on the previous slide. But again, with anybody with basic knowledge of electronics and of soldering and of hooking, of networking and hooking things together, they can build this small personal IoT system. Very, very, in a very affordable and easy manner. Talking about the costs, okay, we came up that the whole system, for doing this multimedia the setup for an individual probably costs in the region of around £300, which is what a medium-end mobile phone will cost nowadays anyway. So totally affordable for quite a few of the people out there. So it's not niche. It's not something which is completely unaffordable. It's something which can be quite easily done, and through devices which are quite readily available for many people. Now, to summarize a bit of our work, here we have 6 video clips. All of them are described below, and each one of them has something to do with the sense of smell. So one, we're cooking spicy curry. The other one, we're preparing a fruity cocktail. Then one is about the launch of a perfume. Another is about a documentary about burning wood, and so on and so forth. So quite a bit of our work was about augmenting audio-video material with olfactory content. So smells and the aromas that you use, where here you have for each particular aroma, you had the video clip it was associated with. What happens is that we edited the video clips so that they were 90 seconds long, and the particular content in which was relevant to the olfaction, to being augmented with olfactory stimuli, was the middle segment between 30 and 60 seconds long, as shown over here. Now, what we were the issue of synchronization, ladies and gentlemen. Now, if you think that, in your audio visual, how many times have you watched a news clip or a newscast where you realize that the video of the person's lips is out of sync with the words that that person is actually uttering? So this is known as lip sync, and research has shown that in order for it to be perceived as the audio of the words and the visual of the lips to be perceived as being synchronized, the delay between the two streams has to be no more than plus or minus 80 milliseconds. Now, in the case of smells, what happens is that smells actually they linger in the atmosphere. Okay, so it's as opposed to audio and video, where when you play a video frame, that frame is instantaneous and has gone after 1/30th of a second, and similarly for audio type of media. Okay, so the audio and the video media do not linger on the screen or on the ears. The aromas do actually linger. So from this point of view, in order for the audiovisual presentation to be synchronized with the olfactory stimuli that we augmented them with, the acceptable synchronization was actually shown to be between plus or minus 20 seconds, which of course is 2 orders of magnitude greater than the plus or minus 80 milliseconds for the audiovisual, which this is much more loosely coupled, and this again, this happens because of the lingering effect of in follow-up work, we were particularly interested, to see, okay, how can we use, all of these effects in a digital setting, all of these olfactory effects in a digital setting. And here we have a word search puzzle, which we used in our research, and that in this particular matrix, probably quite a few of you have already created at some stage, you have words which are hidden. So those words can be, left to right, right to left, top down, bottom up, and diagonally as well. So this actually, this matrix actually contains 12 words, and to spare you any are the particular words that that are there, So for instance, aromatic and sweet and curry and rancid and strawberry and all that. And as you can see, the 12 words there, each one of them has some aromatic connotation to it. So what we did was we had 2 particular groups of participants in this study. One of which was given the straightforward task of, you have so much time to recognize as many words which are hidden in that matrix. And the other group, that was the control group, and the experimental group, in which we gave them exactly the same instruction, but in the background, we were emitting scents, and those scents with a particular type of with words hidden in the matrix. So if you remember, our olfactory emitting device had 4 fans. Each one of those 4 fans had a different scent, and these scents were cyclically played. And for each particular scent, there were 3 words associated in the matrix. Okay, so 4 scents, 3 words for each. 12 words overall. So over here you have the 4 smears used, as well as the 3 scents associated with each word in that particular matrix. So what actually happened was that we did, after doing this study, we did come to the conclusion that the group which was exposed to scents recognized a higher number of words than the group which wasn't, and more importantly, that number was statistically significant. Now, of course, this just shows the potential of multimedia in things like, information recall, in learning, and so on and so forth. But let me just say that multimedia is not by any means. Now, moving on to other work that we did. Again, we were very, very interested to see if we use multimedia in a 360 context, what was the quality of experience of users. So here, we this is another study that we did, and we looked at 3 particular type of videos. One was a video of a lavender field. The user was walking in a lavender field. That was pretty static, pretty monotonous. Then there was a sort of semi-dynamic coffee shop type of scenario in which the user was being prepared a cappuccino. And the other one, which was a highly dynamic one, was a roller coaster scenario in which users went up and down the roller coaster ride in 360. And what we did was we augmented all of these videos were videos in 360, but we augmented them with other types of effects. So things like scent effects and wind effects. Which we can mention. So, for instance, in the lavender field video, which is at the top, That was a 60-second video, and as you can see there at the left, the Navigator sync was switched on with 100% intensity at the beginning, and then we switched it off when at 0% at the end of the video when the video was out. The wind effect, there was a gentle breeze throughout, so we basically had wind fan playing at 30% intensity, which got switched off at the very end. So that was a very simple video. But let us then look at the coffee video. So over there you can see that there was a short, sharp spike in wind. That was when the milk of the cappuccino was being frothed. Okay, so there was a fizz sound. And then, between roughly 5 seconds and 35 seconds was when the cappuccino was actually being mazed. And then after roughly 35 seconds to the end of the video, we switched on the coffee scent because that was when the cappuccino was ready and the beautiful aroma of coffee pervaded the environment. And again, if you're talking about the roller coaster ride at the bottom, at the beginning of the roller coaster ride, participants were at the very top of the structure, okay, ready to go down. So being at the top, there was wind blowing, all right, so it's a wind at 30%. And then between 0 seconds and roughly 25 seconds, they went all the way down to the bottom of the roller coaster ride. Of course, at the bottom of the roller coaster, the wind intensity, the speed was higher, so the wind flowing through the people's hair was at maximum intensity. So that was where the wind was 100%. But you see there that the scent was at 100% either as well. So what was that? Well, the scent over there, ladies and gentlemen, at 100% was essentially the scent of braking, because the roller coaster had to brake at top speed, okay? So it's a mechanical scent, and that is the scent which got emitted with full intensity when the roller coaster was braking at the bottom of the ride, and then slowly it goes away, and the wind goes from 100% to around 50% because you're actually climbing back up again, and so on and so forth. Okay, so this is how we augmented the various videos with Marcy Media. We had 40 participants, all right. They had their breakdown by gender and their age, quite, from quite well spread out. And, there were, in order to prevent order effects, the first 6 users saw the videos with multimedia followed by Marcy Media, whereas the next 6 users saw the videos with Marcy Media followed by traditional audiovisual multimedia. I guess you can see over there, not only the order of sensory effects was varied, but also the particular viewing order of the video clips, right? So the lavender was so to make sure that each video clip was seen in a particular position an equal number of times as all other video clips, thus alleviating any potential order effects with the. So what were the results? Well, first research question, does video dynamism impact user perceived quality and enjoyment? Where these are the graphs, in blue it's multimedia and in green it's Marcy Media. As a general comment, you can see that enjoyment and perceptual quality, the green towers are much higher than the blue towers, irrespective of the dynamism of the clip. And indeed, out of this, the dynamism had an important effect on the enjoyment factor, but not on perceived quality, even though, as you can see there in the perceived quality, it is still higher when Marcy Media was used. Question which we asked ourselves if Marcy Media enhances the sense of reality in 360. And over here we had two different effects that we employed: the olfactory effect and the airflow effect. And here, was the answers. you can see pretty positive results. Now, of course, all of these sensory effects, they can also be perceived as annoying, okay, because you are emitting, aromas in the atmosphere, people are feeling things, on their skin, when there's an airflow effect, and so on. But, it can be something which is people are not used to and they can get annoyed. And here, in respect of the statements, the olfaction effect is annoying and the airflow effect is annoying, people were negative towards that, so this was a negatively worded statement. So scores of 4, which are pretty much the same throughout, actually mean that people disagree with this particular statement. So they did not find it particularly. The same profile is actually visible when we were asking people about the distraction of Marcy Media in 360. Again, people, roughly, 4 throughout, which means that they disagreed with olfactory or airflow effects being distracting to the overall experience. So, it's always good to have this feedback from. Now, here, ladies and gentlemen, is where we start talking a bit about magic, and it's probably my most magical results of my research so far. I wrote a paper on that, the details of which are in the bottom, and it got a Best ICMIB Multimedia Paper Award. So, without further ado, here is the magical result. Now, on 2 levels, it's magical from 2 points of view. One is that it shows that the enjoyment of participants was higher for 360 Marcy Media than from 360 multimedia at any encoding quality. Okay, so it's a clear, statistically significant difference. Okay, you can see a clear gap between 360 Marcy Media and 360 multimedia. The other really, and this is where it becomes really magical, is that if you see, look at the enjoyment between 2.5K and 4K, the enjoyment in 2.5K is actually higher than the enjoyment in 4K, which basically means that people do not notice any improvement in 4K. All right, and indeed, it is overkill to show 360 videos, multisensory videos in 4K, and indeed, traditional audiovisual type of content in 360 at 4K, because people will not notice the difference. And indeed, between Full HD and 2.5K, the improvement in perceived quality is marginal. Okay, so really, the moral of the story is that if you want to go from HD to Full HD, by all means do so, because there will be a marked improvement in perceived quality. In Full HD to 2.5K, you should only be going to the higher quality level if you have the resources. But from 2.5K to 4K, by any means don't do it, because you're getting more for less. You're getting a higher quality of enjoyment at 2.5K for less resources. 2.5K is obviously less computationally demanding than 4K. So really, this is a magical result where, if you'd ask a priori any engineer, they would tell you that 4K quality has to be better than 2.5K, whereas this result, when you actually involve human users, shows that it is not. I will finish by saying that, look, Marcy Media, of course, I've alluded to its potential in learning, in augmented and extended reality right now, but Marcy Media really has to have an end-to-end vision. Why? Because, if you think about multimedia having capture, production, distribution, rendering type of cycle, where you have to have the same cycle, okay, and you have to do multimedia research across all stages of this cycle, and in of issues for the future. So, of course, I'll be very interested, in what happens when we are able to digitize olfactory experiences and gustatory experiences on the internet. There is still a lack of formal representation of Marsimedia, and again, there is more work need to be done in that particular category. Of course, I've already alluded to the impact of wearable Marsimedia by the fact that all our five senses are concentrated on our face. So of course, anybody can wear glasses and have little multisensory devices planted on the bridge of the glasses, or indeed next to the ears. But of course, people wear necklaces and people wear other types of stuff, and again, that can be augmented with multisensory type of devices. This magical experience has shown that one can use Marsimedia for green computing, in order to, with a relatively reduced cost, to get huge benefits in terms of reduced computational demands on the overall augmented reality type of applications. So again, it's very, very quite a few opportunities from that point of view as well. So this is the bibliography. Okay, so quite a few papers of mine. Okay, which you might want to refer. Some other papers which are still interesting reading, and saying that for my sins, I am the editor of the International Journal of Pervasive Computing and Communications. It is not an open access exclusively journal, so you don't have to pay publication fees if you don't want to. It is going to have an impact factor in the latter part of this year. It is Scopus indexed. So it is being indexed by the right metrics. So I look forward to receiving your contributions to this journal anytime soon. With that, attention, and wish you all the very best. Thank you.
So, yeah. So let's conclude this session and thank Professor George for his excellent talk. And as I wrote, he is working with how to transfer smell through internet and other things. So this is their first attempt. And you can see that there are many research papers that has come in IEEE Transactions ACM Computing Survey, which are the journals in this area to go for. And he has been working very sincerely for almost a decade or more than a decade on this particular problem, and they're quite successful in this endeavor. So I think that we should conclude this session and move ahead to session 5 and session 6 for the paper presentation. Thank you all. Ramesh? Professor Srinivas? Should I close this?
Thank you, sir.
We'll close this session and then let's join the session 5 and session 6 of the paper presentation.
Okay, sir. Okay.
Thank you.
Thank you. We are closing this session. We will meet in the session 5 and session 6. Thank you all.